Okay, so the first equation, y equals x. If you wanted to make a quick table, you could. Let's see, if x is -3, what's y have to be? -3. If x is 0, what's y have to be? 0. If x is 2, y is 2. So we're going to get some points here. -3, right there. It's right in there. 0, 0, and 2, 2. And I know it's a line, so I'm only going to make those 3 points, and we can draw it in from there. That is the simplest linear equation we can create. Y equals x. You can see it goes through the origin, the center of our graph here, and it goes across the graph, corner to corner, at a 45-degree angle. Well, let's look at this one here. I'm just going to add a column. I'll make it a table. Make more sense. If x is -3, what's y going to be? What's -3 plus 2? -1. If x is 0, what's y going to be? What's 0 plus 2? 2. And if x is 2, what's y going to be? 4. So we've got -3, -1. That's a point right there. 0, 2. That's a point right there. 2, 4. Right there. What we get here is a line that's parallel to our first one. How has it changed? All that's happened is it's moved up 2 spots, hasn't it?
Where does the -3 come from?
I just made up these numbers so that we can test them out. On all that whole graphing worksheet, remember all the x values are ones I just gave you to use? You just have to pick values for x and figure out what y has to be and plot those points. For this one now, let's make a table for that. Y equals x minus 1. So if x is -3, what's y have to be? What's -3 minus 1? -4. If x is 0, what's y have to be? -1. If x is 2, 1. Perfect. So we've got -3, -4 is right there. 0, 1, and 2, or 0, -1, and 2, 1. 2, +1. That line is still parallel to our first one. How has this one changed? Well, it's just moved down 1 spot, hasn't it? So we see a pattern developing here. This one, we took x and we added 2, a line moved up 2 spots. Here we took x and subtracted 1, and it moved down a spot. Well, let's take a look at this next one. Y equals 3x. If x is -3, y would be, what's 3 times -3? -9. So -3, -9 is going to be somewhere down here. If x is 0, what's y going to be? 0. 3 times 0 is still 0. So 0, 0 is going to be right in there. If x is 2, what's y going to be? That's 3 times 2. 6. So 2, 6 is way up there. So this line goes back to going through the center. It's just steeper. There are 2 things that basically can happen to our equation. We started out with this one here, y equals x, and we said that was the simplest form of equation we could have. And that was this one here, the blue one that goes across corner to corner through the center of our graph. 2 things could happen to it. We could either add or subtract to it, which we saw just moved it up or down. Or we could multiply it, which we saw changed its angle across the graph. So if I have something like y equals 2x minus 3, instead of going through the center, where do you think that one's going to go through? Well, it's going to move it. We subtracted 3. It's going to go down 3 spots. That's where it's going to start, instead of starting at the origin. You can see here, this simplest graph started at the origin, at the center. In fact, this one here even went through the center because it's nothing's being added or subtracted to it. So that number that is added or subtracted in the equation moves the graph up or down from the center. The number that multiplies the x, what did that do up here? What did multiplying by 3 do to the line? It made it steeper. So this line is going to be steeper than normal, like that. Let's explore this number a little bit. That number that describes the steepness is called a slope. The slope is always the number that multiplies x. Slope is defined to be a rise over a run. You might be looking at the 2 and saying, well, that's not a fraction. Well, it kind of is. How do I make 2 into a fraction? Let's put it over 1, right? 2 over 1, it's now a fraction. So that slope of 2 over 1 means that from that starting point, I found this starting point here. We're going to talk about that more in a minute. I go up 2 and over 1. I rise 2 and I run 1. There's a second point on the graph. My graph has to go through those points. This number here that was added or subtracted is the starting point, and it is called the y-intercept, which is just a fancy word for where it crosses the y-axis. Remember, this number line that goes up and down is the y-axis. That equation intercepts the y-axis at -3. So if I want to graph an equation, like this, where am I going to start here? What number's added or subtracted? The 1 is added to it. That means we start from the center, we go up 1, and we're going to start there. So that's our first point on our line, right there, 1 up. From there, the slope tells us where to go to the second point. This is our slope. From there, we're going to go up how far? 2. So 1, 2. And we're going to go over how far? 3. 1, 2, 3. There's our second point. There's our line. Now, one of the things we need to be able to do is we need to be able to look at an equation and determine, just by looking at it, if it's going to form a line. And if it's going to form a line, then we can put it in this form here so that we can graph it quickly like this. So if you have that worksheet with you from last class, did we do 1 through 4 in class? I showed you a graph of the first 4, I believe. Let's go through them again. What was the equation for number 1? Y equals 3x minus 2, so it's going to look something like this, right? Second one? Y equals 6 minus x. So line, something like that. Next one.
Y equals x to the second power plus 2x plus 1.
Y equals x squared plus 2x plus 1. This is going to look something like this. Next one.
Y equals x plus 6 squared.
Squared? Square rooted, right? Okay. That one looks something like this. And remember, that one only has the arrow on one end because it can't go this way any further. It can't have negative numbers. What's number 5? y equals 3 plus 3x. Looks something like that. That one's also a straight line. Number 6.
Y equals 2x.
2x, like this? Oh, to the power of x. Okay. That one's going to look something like this. Like that. That's what it should be if you get enough points in it. Because if x is 0, to the power of 0 is 1, so that'd be 0, 1. If x is 1, 2 to the power of 1 is 2, so you got 1, 2. If x is 2, 2 to the power of 2 is 4, so you got 2, 4. If x is negative 1, 2 to the power of negative 1 is 1 half, so you got negative 1.5. If x is negative 3, 2 to the power of negative 3 is 1 8. By the way, this is something called an asymptote. You don't need to know this word. But this graph will approach the x-axis, but it'll never touch it. It'll get closer and closer to it, but never touch it. Okay, so next one. Y equals x to the third minus 1. Looks something like that. Next one. Ah, that's the fun one. Anybody think they got this one? Yeah? Actually, 2 separate curves. Like that. Because if x is 0, what do you get? Your calculator goes bonkers, doesn't it? It says error. X can't be 0. This is another example of that asymptote thing. X can never equal 0. These graphs will get closer and closer to that, but they'll never touch it. Because if x is 0, 8 divided by x is a bad, bad thing. What are we at? Number 9? 4x squared minus 8. Something like this.
Like, my question with it is, how am I multiplying 4x squared? So am I going...
You gotta do, like, say if it's negative 3, right?
Negative 2 is the top.
Okay, put negative 2. Negative 2 squared is 4. Okay. Then 4 times 4 is 16, then minus 8 is 8.
So we're only squaring what x is, not...
Yep, just the x.
Okay, so
So it's order of operations, yep. Right. And then number 10. 3/4 x minus 4. Something like that. So obviously there's a shortcut to graphing these. Part of it is looking at the equation and knowing what shape it is. For this class, all we're going to really concentrate on is lines. You may graph some of these parabola type things like this one or this one, but you'd graph those using a table. So the big thing we need to do right now is determine how do we know if an equation is going to form a line. So we look at those 4 that form a line, and we compare them to the others. What's different about them? In fact, let me word it this way. What do the ones that don't form lines have that the lines do not have in the equation? A power is the one, exponents. Number 1 is a power on the variable. I'm going to put in here except 1 because a variable by itself has a power of 1, right? So yeah, if we have x squared, that's not going to do it. X to the third. In fact, this actually includes this one here. A square root is actually a power. So this includes radicals, roots. You could actually enter in your calculator the square root is the power of 1/2. It does the same thing. What else? So that includes this one too. How about, is this one number 6 here? What's going on there? Where is the variable there? Variable is in a power, yes. The variable is the power. It's 2 to the power of x. And then finally this one here, y equals 8 divided by x. We're dividing by a variable. Technically, that's the same as number 1 because you could read that as just x to the power of -1. But it happens often enough, we're going to name it separately. These are the 3 things right here that I usually call the 3 don'ts of linear equations. Those are the 3 things that linear equations don't have. So if you look at an equation and it has any one of those 3 things, you know it will not form a line on the graph. So then, will that one form a line on the graph?
No.
Why not? There's an exponent, but look at where it is.
It's also
3 squared is just 9, right? That's just y equals 2x plus 9. That is a line. How about this one? No exponents, not dividing by any variables. That is a line. How about this one? No, there's an exponent and it is on the x. That is not a line. How about this one? There's no exponents. What am I going to have to do with that 3x? I have to multiply it out and it will turn into an exponent. So no, that is not a line. How about this one? Y equals x divided by 5 is the same as y equals 1/5 times x. That's a line. We can't divide by the variable. We can divide the variable by a number, but we can't divide a number by the variable. How about this one? Yes, there's a power there, and it's near the x, but it's on the 3. That's 3 to the power of 5, which is 243. How about this one? Somebody be brave. We're dividing by x. Hey, at least you gave it a shot.
I know.
How about this one? Yes. How about this one? No, it's 2 to the power of x. How about this one? If I try to isolate the y, here notice all these other ones are y equals. If I isolate the y by dividing by x, this is going to become y equals 12 over x. I'm dividing by x, so no. How about this one? Any powers? Nope. Are we dividing by any variables? Nope. That one's fine. How about that one? Yeah, that was good. How about that one? Nope, square root is on the variables. That one's no good. So we can see what equations are going to be lines. And up above here, we saw a little view of what happens when we know it's a line, how we can graph it quickly. If the equation is in this form, we can graph it really quickly. Where does that one start out? From the center, we're going to go down 3. Why do we go down 3? There's a minus 3 on the end of that. Because 3 being subtracted from the x. From that point, where do we go? Well, 1/2 x means we go up 1 over 2. Very good. And our line goes through those points. From the starting point, yes. Where's this one start? Yeah, even though it's first here, it's still the number being added or subtracted. So we go up 2. We're starting there. From there, what do we do? Up 2 over 3. Very good. How about this one, where we're going to start? Up 4, so right there. From that point, now it's a negative slope. The negative always goes with the rise. So the negative tells us positive is up, negative is down. The run will always go left to right. Run always goes that way. So this is a negative 3/2. From this point, we're going to go down 3 and over 2. There's my line. Does that make sense? Where's this one going to start at? Negative 1, right there. And from there we go, that slope of negative 2, we got to make it a fraction by doing this. Negative 2 over 1. So from there it's going to go down 2 over 1. If I'm worried about making this straight, I can go down 2 over 1. I can keep going down 2 over 1, down 2 over 1. I can just keep going to make sure I can get my line straight. So I want you guys to try some in your notes. Try those 4 quick, and who knows. So the first one up here, where are we going to start? Up 3. From there we're going to go down 1 over 4. Something like that. Next one, where are we going to start? Down 1. From there, what are we going to do? I mean, the 2 over 1s will go up 2 over 1. Right? This we got to put the little 1 in the denominator, so we know we got to go over 1. Just like that. How many got those first 2 to look about right? 1 out of the first 2? 1 out of the 2 is the first 2? Okay. Second one, where does it start? Or the third one, sorry, this one, purple one. At 4, right here is going to be the first point. From there, we make that a negative 3 over 1, so we're going to go down 3 over 1. Okay. Got to remember to go over 1. So that's the purple line. How many of you had that one right? Just a couple. They all look the same. How about this one in red? Where's that one start? Down 2. From there, what do we do? Down 1 over 3. Right there. Looking at this one, where would we start? Tempted to say +1, right? Why is that not going to work? What do we notice about all these equations here that we've graphed so far? It's y by itself. It's always y equals. The y is by itself on one side of the equation. This one, not so much, is it? So we have to get y by itself before we can use this shortcut that we used here to graph it. What's keeping y from being by itself? The +2. How are we going to get rid of it? Subtract 2. Now when we add or subtract to an equation, we only have to add or subtract to one piece on each side. So we can subtract that 2 and make it go away. Leaves us with just y. On the other side, I just have to subtract 2 from one piece. And that's going to be from the 1, because I can't subtract 2 from 1/2 x. So the 1/2 x doesn't change. What's 1 minus 2? -1. So this one's actually going to start at -1 right here. And from there it's going to go up 1 over 2 right there. What is going on here? The y is being multiplied by 3. So how do I get rid of it? Divide by 3 will make it go away. Now when I multiply or divide an equation, I have to do it to every digit, every piece. So I divided the 3y, which divided out the 3. Over here, when I divide by 3, I have to divide the 2x by 3. Now I'm going to show you a little trick. Remember we said division and fractions are kind of interchangeable, different viewpoints of the same thing. 2x divided by 3 can just be 2 over 3x. Then I still have to divide the -6 by 3, which will be what? -6 over 3, which is -2, right? So where's that one going to start? -2, and from there it's going to go up 2 over 3. Perfect. How about this one? Here's my y. What's keeping it from being alone? Well, it has been multiplied by 2 and 3 has been subtracted from it. Which one am I going to get rid of first? The 3. I'm going to add 3. That's gone. This is 2y. And remember, I only have to add 3 to one piece on the other side. So I'm going to add it to the 1. So this is now 3x instead of +1, it's +4. It wasn't the bigger one I get rid of, it's the one that's done last. If I look at this side of the equation here, what was done to y, you would have to first multiply by 2, because order of operation says you multiply before you subtract. And then you would subtract the 3 from it. When we take it apart, we got to go backwards. We take off the last piece first. So we added the 3 to get rid of the 3. And now we're going to do what? Divide by 2. Get rid of the 2. So that's why, remember when we divide, we have to divide each piece. 3x divided by 2? 3 over 2x. What's 4 divided by 2? 2. So where are we going to start over here? Positive 2. And from there we're going to go up 3 over 2. Any questions there? Now I'm going to give you a word of warning here. When we are graphing, you go up and down first, and then you go side to side. In fact, we go up and down twice, because the first thing we did, the positive 2, we started at the center and we went up 2 to get to that, right? Then for the slope, we also went up first. We went up 3 and then over 2. So we went up and down first, and then we did the side to side. But if I were plotting a point, let's say I were asked to plot the point 3, 2, I would go over 3 to get to x equals 3. Then I would go up 2. That's the point 3, 2. So when I'm plotting points, I go side to side first, then up and down. So you have to keep that straight. That's one of the tough things for people starting out graphing, is keeping that straight. Because when you plot points, which is the first thing we learn, you're always going side to side first, then up and down. But when we're graphing, it's always up and down first and then off to the side. I'm going to have you guys try a few here. Try those 3 quick. You good to go, or you need a minute yet? Let's try this first one. What do we have to do the first one? Divide by 2. So this is just going to be y. What's x divided by 2? Yeah, it's treated as 1x, so it's 1/2 x, or 1 over 2 times x, minus negative 6 divided by 2 is negative 3. So where do we start? Negative 3. And from there we go up 1 over 2, right there. Next one, what do we have to do with this one? Add 3. So that's gone. I got to add 3 over here. So I got y equals, what am I going to get on the right side? Does the 2x change? No. Negative 1 plus 3? Positive 2. Those negatives are still giving you a fit, aren't they? So where do we start there? Positive 2, and from there we go up 2 over 1. Good. And finally, the bottom one. What do we do there first? Just like solving, oops, that would make sense if I put the right variable there. Does that help? I'm going to give you a minute to try that one over. Sorry about that. So what do we do first? Subtract 1. So 3y equals 4x plus 6, and then divide by 3. Y equals 4 over 3x plus 2. Where do we start? Positive 2. Up 2, and then we go up 4 over 3. Not so bad?
That one was way easier when we changed it.
Yeah, once you actually put a y in it, it makes more sense. Sorry about that. So now this one, the x and the y are on the same side, but we still need to solve for the y. And we're going to pretend that the x isn't even really an x. It is just part of this number. So when we start to solve this, we would treat this as though it's just 3 plus 2x. We're going to subtract, or 3 plus 2y. We're going to subtract the 3x. Make it go away. So we have to subtract 3x from the other side. So 2y is all that's left here. What is 4 minus 3x? We can't combine them because one's a whole number and one's an x. So it's just 4 minus 3x. Then what? Now we divide by 2. Y equals, what do we get? You got it. 2 minus 3 over 2x. So that means we start at 2, and then from there we go down 3 over 2. So I'm going to have you guys try one of those. Try that one in your notes. Where do we start? Subtract 3x. Negative 5y equals 10 minus 3x. And then? Divide by negative 5. So 10 divided by negative 5? Careful. Negative 3x divided by a negative 5. Negative divided by negative is a positive 3 over 5x. So where do we start then? Well, it is. It's a negative 3 over a negative 5. But a negative over a negative is a positive. So where do we start? Negative 2. And then from there we go up 3 over 5. I think that is a good point to take our break. So let's do that. We'll come back at 4:30 for some more.